Suppose a polynomial of degree 4 with rational coefficients has the given numbers as zeros. Find the other zeros. Okay, in this problem we are given a polynomial, and this polynomial has a degree of 4. So this is polynomial and has a degree of 4. And the other piece of information, which is very important, it's given that this polynomial has irrational coefficients. So we got rational coefficients of this polynomial. So the an's, an minus 1, an minus 2, etc., these are rational numbers. And we are given 3 zeros for this polynomial, and we need to get the rest, other zeros. The first and most important idea that this polynomial has a degree of 4. So we know immediately that this polynomial has at most 4 zeros. So the polynomial has at most 4 zeros. And we are given 3. So we might have another one, the fourth one. And recall something. Recall the irrational zeros. If a plus c radical b and a, b, c are rational, and b is not perfect square, is a zero of f of x. F of x is a polynomial here. F of x is a polynomial. So suppose we are given this as a zero of the polynomial, and a, b, c, these are rational numbers, and b is not a perfect square. For example, suppose that we have 2 plus 3 radical 2. So this is okay. But suppose we have 2 plus 3 radical of 4. This is not okay. Why? Because this one is not irrational. This is rational because the square root of 4 is 2. So we got 2 times 3 is 6. 6 plus 2 is 8. So this is 8. This is rational. But this is irrational. This guy is irrational. So suppose that we have this case, something like this. 2 plus 3 radical of 2. Okay? And a can be 0. A can be 0. For example, this number can be 0. Number 2. So suppose we have this as a 0 of the polynomial, then immediately we can say its conjugate. Its conjugate is what? Also a 0. Let's look at the zeros we have. The first 0 is rational number. This is rational number, negative 2. And also this is rational number, 12 over 5. It's rational. However, radical 2 is irrational. Radical 2 is an irrational 0. It's an irrational 0. So what does this mean? It means that when radical 2 is a 0, then its conjugate is a 0. What is the conjugate of this number? Just you switch the sign of this radical. So it's going to be negative radical of 2. Because again, what is the conjugate of a plus c radical b? The conjugate is a minus c radical b. These are the conjugates, okay? These are the conjugates. In our case, we have square root of 2. Square root of 2. So c is 1 and a is 0. So this is what we have exactly. So what is the conjugate of this? 0 minus 1 radical of 2, which is obviously negative radical of 2. So this is also another 0, is another 0. Then we are done, because how many zeros we have now? We have 4 zeros of a polynomial with a degree of 4. That's it. So we don't have any other zeros. Suppose a polynomial function of degree 4 with rational coefficients has the following given numbers as zeros. Find the other zeros. Again, we are given two zeros. One of them is a complex number, which is negative I, is a complex number, and the other one is an irrational number. So we have one of them as a complex, and the other one is an irrational. And again, we have a polynomial. This is important to know. And this polynomial has a degree of 4. So immediately we are going to have at most 4 zeros. At most 4 zeros. Now we are given 2 zeros. Can we find another 2 or no? So let's recall two things. One of the points that I mentioned in the previous video regarding to the irrational. So from this one we can immediately say, because we have an irrational 0, then its conjugate actually is another 0. So immediately we can say, because 3 minus radical 7 is a 0, then the conjugate of this is a 0. 3 plus radical of 7. You can refer to the previous video about this. The second one is a negative I. Negative I is the complex number. And we need another point here. What is the point? If a complex number a plus bi, and b is not 0, is a 0. Suppose you have a complex number as a 0 for this polynomial, and b is not a 0, because if b is 0, we will not have a complex number, we will have a real number actually. Okay, so we have this as a 0, a plus bi, then this function, this polynomial has real coefficients. This is important as well, because to apply this idea, the polynomial function has to be, or has to has what? Rational or real coefficients. Okay, it has to have real coefficients, and we do have real coefficients, because it says we have a polynomial and we have a rational coefficients. The rationals are real already. The rational coefficients are already real coefficients, so we are good. So if you have a complex number as a 0 of the polynomial, and this polynomial has real coefficients, then the conjugate of this 0 is also a 0. So the conjugate is also a 0. Is also a 0. So negative I, what is the conjugate of this? Again, negative I is written as what? This is a plus bi, right? So this is 0 minus I. So what is the conjugate of this? The conjugate of a plus bi is a minus bi. So the conjugate of 0 minus I is 0 plus I, which is positive I. So what is the conjugate of negative I? Is positive I. Okay? So we have another 2. We found another 2 zeros for this polynomial. Is it enough? Yes, it is, because we have a polynomial of the degree of 4. That's it. So the other 2 zeros, the first one is 3 radical of 7. The other one is positive I. Then we are done.